With another real life example. Okay, in this case we have Eula needs to buy binders that cost $4 each and notebooks that cost $2 each. She has $20. So in her wallet, I want you to just imagine right now you open your wallet, you have $20, so it doesn't matter what it is, $20 bill, two tens, four fives, 20 singles, whatever. Okay? And you're walking to the store and you're at like Staples or Office Max or Target, wherever you go, and you want to buy a bunch of binders and you want to buy a bunch of notebooks, right? But you only got that $20. So again, these are things that you have to think about all the time, right? But you just don't see it in the view or the perspective of algebra, but it's there. And so it says the inequality, okay, 4x plus 2y is less than or equal to 20. So we're gonna write that here, 4x, okay, plus 2y is less than or equal to 20, okay. Now think for a second, like why are they using less than or equal to 20? And when you think about it, it's like, all right, if you have $20 in your wallet and you need to buy these binders, does that mean that you need to go and spend all $20? Maybe you just need one binder and then one notebook. Now maybe you need one binder and two notebooks. The point is that you don't have to spend all of it, but just know that you have that maximum of $20 there. Okay. X represents the number of binders. So X is binders, the number of binders, and Y is the number of notebooks. All right, now the question here says that we want to find the x and the y-intercepts. Now, an intercept, if you remember, is simply where you have the function, I'm just going to call it this line here, okay, just where it crosses the y and the x. So this is a y-intercept, and this would be an x-intercept. See how it's crossing the x-axis, and over here it's crossing the y-axis. Now what's very special about this is that when you have a y-intercept, so a y-intercept where it crosses the y-axis, okay, we know that x is equal to 0. Okay, that's always going to be the case. If you were to choose a point, so let's just say I draw this and I draw a point here, and let's say that this is 4, right? So this is 1, 2, 3, 4. This coordinate would be 0, comma 4. The x is always going to be 0. Down here, okay, you have an x-intercept, and so when you have a line that crosses the x-axis, y is going to always be 0. Okay, always, always, always. So I'm going to leave this here. I'll get rid of this piece so it doesn't look too hectic. And they're asking now, identify the x and the y-intercepts. So the way that I like to do these is that I like to write x-intercept. Okay, I like to draw a line going down like this. It's called like a t-chart. And the reason why I'm using a t-chart is because we're actually going to be using this a lot more as we move forward in algebra. And I know that for the x-intercepts, what did we say that we had to set equal to zeros? So x-intercept, so we're going to set y equal to 0. So I'm going to take the same equation, inequality here, so 4x plus 2. Now when I say set, I'm going to replace this y, see, because this was really 2y, right? I'm going to replace that y with a 0. Okay, excuse my handwriting. Okay, it's less than or equal to 20. And then I'm just going to solve this. So 4x plus, this is going to be 0, less than or equal to 20. Okay, if you add 0 to anything, it stays the same. So 4x less than 20. Okay, this kind of like disappears. Divide both sides by 4, and we get that x is equal to 5. Now, I'm not going to put the sign here only because we're not going to be graphing this point. This is just for us to help determine where it's going to cross the x-axis. So I'm just going to write x equals 5. And I'm only going to do this when I'm looking for the x and y-intercepts. So I know that right here it's going to be crossing at x is equal to 5. Here's my x-axis, and here's 5, right? 4, 5, 6. Then for the other one now, the y-intercept, where did we say we're going to do y-intercept, set x equal to 0. So we're going to set x equal to 0. And I guess the way you can memorize this, or not memorize, right, but a way to better recall it is that if you're looking for the y-intercept, the opposite variable x is what you set equal to 0. Okay, so we have now 4. Now again, here's my x that would have gone there, but I'm going to replace that with a 0 and keep everything else, plus 2y, right? So 4x plus 2y, just replacing the x for 0. keeping everything else the same. And this becomes 0 plus 2y is less than or equal to 20. Okay, 0 plus 2y, when you combine anything with a 0, it stays that way. It stays the same through addition. So we can kind of just get rid of it. Less than or equal to 20, and then when you divide both sides, we get that it's going to cross the y-axis at 10. So I'm going to come up here, 1, 2, 3, 4, 6, 8, 10. And I know that my line is going to be connected between here and this point. Now, I just don't know if it's a dashed or a solid line. Remember, with inequalities, it has to be one or the other. So I'm going to look right here at my inequality symbol. You see that this solid line underneath here? Okay, this is going to be a solid line. So I'm going to go over to my tool that I have here, and make a nice solid line between there and there. Okay, I'm not sure why it's always green. And from there, we need the shade. Okay, so being a solid line, this is also a less than, okay, or equal to, so we're going to shade less below. So wherever this line is coming, see how this line is coming down? You always read a graph from left to right. So we're starting at the left and reading to the right. It's going down, so we're going to shade right below it. All of this. Okay. Now, for those of you that are a little bit confused about this whole x and y intercept thing, let me just take a moment on the side here, and let's just put this into y equals mx plus b form, just so that you're able to see that we get the same answer anyway. Okay, so if we were to get into a slope intercept form, you know that the y has to be by itself. So we would subtract 4x on both sides. Bam, bam. This comes right down. So you get 2y less than or equal to negative 4x plus 20. All right. And if we continue dividing each term by 2, we get y is less than or equal to negative 2x plus 10. Okay. Now remember that negative 2 is going to be our slope, so we're going to make that into a fraction. And if we start at 10, I notice a good luck, watch, we're starting back at 10, go down to, right, down to, right 1, down to, right 1. See how perfect it overlaps anyway? So the only difference is that although this might be easier, it's not easier, but it's like less work, I guess, to get to the answer. It's more dots that you're making, versus with this one, you're just going to be getting 2 dots, and then, because you only need 2 dots to make a line. So the questions now are, what is the greatest number of binders Euler can buy? Well, I'm looking at this, I'm like, well, how do I know what's binders or not? Okay, well, that's where you have to go back. You see over here on the last 2 lines, it says x represents the number of binders. So I'm going to look at my x here it is right here. That means this whole line is number of binders. And so then this would be number of what is this, notebooks? Oh man, it has to be a big word. Notebooks. Writing sideways. Here we go. Okay, so what's the greatest number of binders that she can buy? So we're looking down here. Okay, now we're looking to see, remember, all of this is covered. All of this is covered, right? So we're looking to see what's the maximum, and the maximum occurs right there. Okay, now what number is that? It looks like it's between 4 and it's between 6, so it looks like 5. Okay, so 5 binders. And what is the greatest number of notebooks? That's this is y-axis here. Okay, we're gonna go up to the highest point. Okay, see how it doesn't go past here? This was 10 notebooks. So this would be 10 notebooks. And then finally, they just want to ask you now, if Euler buys 7 notebooks, what is the greatest number? Oh, I can't even see what happened here. What is the greatest number of binders that you can buy? So I'm going to write on the side here notebooks. Now, what variable was notebooks? Do you remember? Yeah, it was definitely going to be the y. So I'm going to write y is equal to 7. Now, they're telling us how many notebooks she needs to get, like hands down, right? Like she needs to get this number. So what we're going to do is we're going to go back to our inequality. 4x plus 2y is less than or equal to 20. And here we're going to just substitute the 7 for the y. So this becomes 4x plus 2, right? See how everything's the same? going to replace the y for the number that it's equal to, 7, less than or equal to 20. This becomes 4x plus 14 is less than or equal to 20. Okay, continuing this, we're going to subtract 14 from both sides. It's going to be a little bit tight here. So 4x is less than or equal to 6. And I'm just going to continue here. So 4x is less than or equal to 6. If we were to continue solving for x, we get that x is less than or equal to, now when you put this in the calculator, this actually becomes 1.5. Okay, and that doesn't just mean 1.5. X was the number of binders. So when she goes to the store, she needs to be able to buy 1.5 binders. Okay, and this is less than, so that means that she can't go past 1.5 binders. Well, it's not really true that you can buy half a binder. So then how many full binders can she actually go and get? Right, even though it allows her to get 1.5, we want to take a whole binder. So one binder is the only thing that we're allowed to get if she buys 7 notebooks. Okay, and that's it for these real world problems. I'll continue uploading another one. Let me see what the other one's going to be. Okay, it looks like another one like this about cafeteria and lunches.